Hello and good morning, everyone. Hope you had a great weekend. Just wanted to take a look at where we are in our schedule. Last class, we talked about more of the slope-intercept method and in particular parallel and perpendicular lines. I had given you some problems due out of the packet, and then I also asked you to do a couple of problems I put here at the end here, number 1 and number 2. To do those also for homework. So it's just one problem from the homework and then these 2 problems. We can talk about that in a moment. And then today, what we're going to do is cover functions and function notation. And then there will be a homework assignment out of that section. Next class on Thursday, we'll do applications, which will be word problems. And then at that point, we will start to get ready for the next test. Just to point out though, remember we did skip a section. We did not do percent, proportion, conversions. We did not do that. We're going to move that to later. So just keep in mind that all of this here we have not covered. So it will not be on the test. We'll talk about this more when we get closer to the test, which is what, 2 weeks from today? Yeah, 2 weeks from today. Any questions over what we're covering? How about questions over the 3 homework problems? Anything from there?
I will say I had a hard time, at least for me, for the first and the second problem. I had a really difficult time trying to figure out a correct equation. So how it says, I think the very first part of the problem is sketch it, I think.
Yes.
And then and then so it was the part after that that I really had a hard time with finding an equation that would match.
Okay.
Or that would work.
Why don't we do this one? We'll do this one together, all right? Because this is precisely the type of problem you will see on the test. So you're given this linear equation in 2 variables here, right? We have x and y. We have an equation, right? And it's linear because the powers on x and y are both 1. So we know that this is going to be a line. So part A is to sketch it. So if I were to sketch this line, I have 2 options, right? When it comes to sketching lines, 2 options. One option is the intercept method where you find the x and y intercept. We can do that as long as it's not a vertical or horizontal line. How do I know this is not vertical or horizontal right now, just by looking at it? How do I know that?
Because it doesn't have an X. Oh no, it does have an X. Okay.
Yeah, if the equation contains both variables x and y, then it has to be a non-vertical, non-horizontal line. If it's just x or just y, then you're either going to have vertical or horizontal. Okay, so I know it's not vertical or horizontal, so I can do the intercept method. The other thing is to do the slope intercept method where I solve for y. So let's do the slope intercept method because it was the second method we learned. Let's try and solve for y, okay? I think that'll help us when we do part B, C, and D, B, C, D, and E. So I'm gonna solve for y. So I'm gonna try and get this by itself first, the 3y. So to get the 3y by itself, I have to subtract 5/4 x on both sides. That way it'll go away on the left. The left-hand side will be 3y equals, now on the right side, I have these two. I can't put them together because one of them has x, the other doesn't. But I am going to put the term that has x first, and then I'm going to put the plus 1/8. Okay, we good? I need to get y by itself. How do I get y by itself now?
Divided by,
Divide by 3. Okay, now this is where things can get a little bit tricky because, you know, dividing 3 by 3, well, that's not that big of a deal. But on the other side, you have to divide both of these by 3. So we have to think about what this means. I'm taking -5/4. I'm looking at this first one here. Don't worry about the x, just worry about the numbers. I'm taking -5/4 and I'm dividing it by 3. So what you need to realize there is that you're dividing by a fraction, right? 3 is really 3/1. And the reason why I think that's important is because if you look at it this way, you can rewrite it as 5/4 divided by 3/1. And we learned that already, how to convert division, right, into multiplication, keep dot flip, right? Remember that?
yes,
So I will keep the first fraction, turn the division into a dot, multiplication, and then flip the second one, and then multiply straight across. So when I multiply across, I get -5 over, and then multiply across, I get 12. So that's going to be the number in front of x. Let me continue here. We have the left side is y. The right side is -5/12 x plus, now I need to do 1/8 divided by 3. Same thing. I have 1/8. I'm dividing it by 3, which is the same as 3/1. That's the same as 1/8 divided by 3/1, which is keep dot flip, keep the 1/8 dot flip 1/3. This becomes 1/24. Multiplying straight across. Okay, this is the equation of the line. I haven't graphed it yet, but I want everyone to make sure you understand that this looks like y equals m, right? X plus b. And that right there is the slope intercept form of a line. We know just by looking at this, that this positive 1/24, that's my y-intercept. And we also know that this -5/12 is my slope, which is equal to my rise over run, which in this case, because it's -5/12, this means I go down 5 and go to the right 12. Any questions there? Graphing it's going to suck. I'll admit it. It's going to suck because this y-intercept is a hard number to actually kind of see on your graph. So let me do it. Okay, I'm going to try it right here. I'm going to put some grid paper here. It might help us. Okay, so here comes my graph. I'm going to draw the x-y axes right now. And where do I start? Where do I start when I go to graph this? What's the first thing I put?
You number the y and x axes and plot the y-intercept.
Okay, good. So if we have this line in the form y equals mx plus b, we will always start with this y-intercept. And we need to put that on the y-axis. So I need to go to, well, 1/24. That's a very small number, right? You could do it on your calculator. Where's my calculator? It's a decimal. It's a very small decimal. 1 divided by 24 is about 0.041666. Again, here we get 666. So that just means you just put a point just up just a little bit, right? Like let's say that this is 1 here. Would you all agree my y-intercept is just really just barely above the x-axis? Do y'all see I just moved it just up a little bit? Y'all see that? So that point lies on our line. Now, to get to another point on our line, we only need 2 points to draw a line. To get to another point, we're going to move down 5 and to the right 12, right? Down 5 and right 12. Let me do this. So from here, I go down 1, 2, 3, 4, 5. I should land somewhere right there. And then to the right 12, that's going to be way over here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like I have a dot right about there. And then I connect those with a straight line. Oh, this program is always so hard to connect these. There we go. There we go. Okay, so that is the graph of y equals -5 over 12x plus 1 over 24, which is the original line. So that's part A of the problem. Got it? Questions? Part B, find the equation of any line you want that is parallel to this line, to that given line. Okay, so what does it mean that the line, so we're going to come up with an equation for a new line and we get to choose it. We just need to make sure it's parallel to that line that we just drew. So what can you tell me about the slope of this line we're talking about? If they're parallel.
Doesn't the slope need to be the same?
Exactly the same, right? Exactly the same. The only thing that really needs to be different is the y-intercept, right? And then it would be a different line. So why don't I do this? I'm just going to make one up here. I'll put it up here. How about I do y equals, well, I know the slope has to be -5 over 12, right? I know that. And then x, and then I can do plus, I can do any y-intercept I want. So I don't know, how about 6? There. That line would be parallel to the line that was given. Now, how do we know it's parallel? Well, let's do part C, which is we're going to sketch this. So we already know here, again, my y-intercept is 6 this time, and then the slope is the same slope, right? So when I go to graph this line, I'll do this one in blue. I start with my y-intercept. Let me bring this guy down here. Oops, I don't want to do that. Let me bring this guy down here so we can see it. So I'm going to start with my y-intercept. I'm graphing this. I go up 6. So 1, 2, 3, 4, 5. Here's 6. Does everyone realize I could have chosen any number here for the y-intercept? Right? Anything I want. I just need to make sure the slope is the same. That's what makes them parallel. So from here I go down 5. So down 1. Let me see. 1, 2, 3, 4, 5. And then over to the right 12. 1, 2. Oh, I forgot to put my dot up here. Okay, so down 5 to the right 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That puts me here. And now if I put a line between those two, this will be a different line, right? This will be a different line. It's not the same as the first one, but they are parallel. Does that make sense, Emily?
Yes, it does.
Okay. Now for part D, we do the same thing. We find the equation of any line we want, but this time we need to be perpendicular. So what's the relationship between the slope now? It's not the same. What is it?
Is it the y-axis or the y-intercept?
Is it the opposite, like the reciprocal, but opposite sign?
Yeah, so what we know is that to be perpendicular to the original line, remember the original line has a slope of -5 over 12, right? -5 over 12. To be perpendicular, the slope has to be that number flipped over and then change the sign. So instead of -5 over 12, the slope of our line needs to be 12 over +5. Do y'all see how it's just this same slope flipped over and changed the sign? That's what it means to be perpendicular. Okay, so there, that would work. Now, I can do any y-intercept I want here. So think about what you're going to have to do here. What is this slope telling you? Rise over 1. You're going to have to go what?
Up 5 and right 5, or up 12 and right 5.
Up 12, right 5, right? I'm going to have to go up 12 and right 5. So on my graph, I'm going to have to go up 12, right 5. So I'm going to put a y-intercept, I don't know, down here. That way it'll be easy to go up 12 and right 5 and still stay on the graph. Does that make sense? Like if I do a y-intercept of, let's say 6, then I'm going to have to go up 12 and over here. I'm going to be off my graph. So I'm going to be somewhat clever in this. I'm going to pick my y-intercept to be down below a little bit. I'm going to say negative, I don't know, -8. Does everyone understand that this -8 is completely up to me? The thing that's not up to me is the slope. The slope must be 5 over 12. Questions? Okay, so here we go. I'm going to graph this now. And we'll do this one in green. Okay, so I start out at -8, my y-intercept. So down 8, 1, 2, 3, 4, 5, 6, 7, 8. Here's -8. I put a dot. And then from here, I go up 12 into the right 5. So up 12 would take me, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I should be here at 4. And then to the right 5. 1, 2, 3, 4, 5, right there. Now, when I draw a line between these two, it should be perpendicular to those two lines. Come on. Come on. Come on. I think that's probably as good as I'm going to get it. This program doesn't allow me. There we go. That's not bad. Okay, so there you go. So notice that these lines hit at perfect right angles, 90-degree angles. The first two lines we drew were parallel to one another, right? And the third line we drew was perpendicular to both. Does that clear things up, Emily?
Yes, it does. I will say I did the other equation first, and
Okay.
so I didn't get as far as this equation.
Yeah, okay. Any other questions on this concept? Okay. Then we are going to move on. We're going to talk about functions today, functional notation, how to evaluate functions, how to read a graph and determine function values. So today is all about functions. Now, the first thing we have to do is figure out, like, what is the definition of a function? So there is a mathematical precise definition for a function, which I will give you in a moment, but I want you to look at a function in kind of a different light first. If we take, let's go and look at what we've been doing. Let's say we have a line, y equals, let's say 3x plus 1. So let me just ask you, if I give you an x right now, okay, if I give you an x value, I tell you x is, let's say 2. Will it be pretty easy for you to tell me what y is? If I just say replace the x with 2, could you just pretty quickly tell me what y would be?
Yes.
Yeah, right. You just plug 2 in. 3 times 2 is 6. Add 1, you get 7, right? If I give you another value of x, like 10, you just multiply 10 times 3, add 1, you'd be done, right? So if you plug in an x, right? If you plug in some value of x, it's very kind of simple to figure out what the y is. Yeah, would you agree? Kind of. Now, what about the other way around? What if I just give you a y value right now? Would it be as easy? So let's say I tell you y is 15. Would it be as easy for you to figure out what x is? I'm seeing some heads saying no. It's not as easy. You could do it, but it's not as easy. Would you all agree with that? I mean, because you'd have to, like, if this is 15, then to figure out what x is means you'd have to subtract 1 on both sides. then you'd have to divide by 3. And then you could tell me x is 14 over 3, right? That's a little harder and more involved than the other way, right? When I give you what x is, because all you have to do is just plug in the x, multiply by 3, add 2, you're done. So the reason why it's easier to do it the first way, the reason it's easier is because this equation is solved for y. It's because y is by itself on one side of the equation. So if we think about this visually, if I give you an x, okay, then you can pretty easily figure out what y is, right? This is kind of easy to do for this particular equation, right? I give you x, you can tell me y. As a specific example, when we plug in 2, 2 comes over here and it spits out to be a 7, right? 3 times 2 is 6, add 1, you get 7. So this equation is easy to work with if I start with x, right? Going the other way, right, backwards, harder, right? It's harder to do. And the key to this, again, is the fact that it's solved for y. So what we do is we start to look at more complicated equations, things that are not linear anymore. So this was a linear equation, but let me give you another one. So totally different example. What if I tell you y is equal to x squared minus 3x plus 1? So if I give you an x right now, and you try and tell me what y is, will that be easy? So let's say I give you the number 2. Could you tell me what 2 gets sent to if x is 2? It would take a little bit of work, right? We'd have to take this, put the 2 there, 2 squared, minus 3, put the 2 there, plus 1. So 2 squared is 4. Negative 3 times 2 is minus 6. Add 1. And then these two together, that's negative 2 plus 1. We should get negative 1 as an answer, right? Negative 1. So it was a little more work, right? But we could do it. How about if I give you a y value? What if I give you a y? What if I tell you y is, I don't know, I'm just gonna make it up. What if I tell you y is 10? Are you gonna be able to tell me what x gives you that? So if you take this equation and replace the y with 10, that is going to be very difficult for us to do. In fact, this is called a quadratic equation, and we have a method for solving this. We haven't talked about it yet. But do you all agree that this is hard? I mean, I'm not just like this. I just replaced the x's with 2's and just calculated it, right? Here, I replaced the y with 10, and now I have to figure out what x is. Not so easy. The problem before, we could do it because we could just like move things around and get x by itself. But this is much harder. So hard. This is actually really hard to do. And this up here, again, was somewhat easy. Yes? So anytime we can figure out a variable easily, okay? So in this case, we can figure out y, right? I'm going to type it up. If we have an equation which is solved for y, then it is usually pretty easy to find y if x is given to us. Right? That's basically in words what I've just tried to demonstrate to you. If you have an equation where it's solved for y, you've got y by itself on one side of the equation, then it's usually pretty easy to figure out what the y value is if I tell you what x is. Agreed? Understand? Yes? Yes. In this case, we say y is a function of x, okay? Y is a function of x, meaning this: you can figure out what y is if someone simply gives you x. So if you want to know why, someone's got to hand you X. Going back to the two examples. If I want to know what Y is, then someone just needs to give me X and I can figure it out. Here, if I want to know what Y is, someone just has to give me X and I can figure it out. So when we have this scenario where Y is solved for, right? Y equals something, then we say Y is a function of X, and we use new notation, okay? So here's the notation. We replace Y with this symbol. And I know a lot of you have seen this. F with a parenthesis and an X inside. So let me show you this in action. If we have the problem that I had before, 3x plus 1, then this is solved for Y, right? This is solved for Y. So I can say that Y is a function of X because it's solved for Y. So what I'm going to do is I'm going to replace the Y with this symbol, F with a parenthesis around an X like that. And this is a new notation that we use. It's called functional notation. And what's nice about functional notation is that now if I want to tell you to plug something in, it's very easy for me to tell you to plug something in. So if I ask you now, find f of 2, okay, f, and I replace that x with 2, then all you're going to do is rewrite this equation and replace the x with 2. The way we say this, like in words, you say f of 2. The way we say this is f of x. So same example, I'd like to ask you now to see if you can figure out what these are. So find these values. Find f of 0, f of -4, f of 1/2. Okay, I want you to work on your own here. These three problems, we'll call it A, B, and C. So all I'm asking you to do is take these values, right? And write this equation down and replace the x with 0, -4.5, and you're gonna have 3 different answers. Okay, let's take, I don't know, maybe 3 or 4 minutes. I think the last one's gonna be the hardest one because it has a fraction in it. I don't want any decimals for answers. I want everything to be fractions. So see how you do, and then we'll run through them real quick. I'll give you 4 minutes. See how far you get. If you happen to finish those, I'm going to give you one additional problem. Does anyone have any questions? Another minute or two, we're gonna go through at least the first three.
For D, are we able to solve that because there's no X in the equation? Like, it's only 130?
Yeah, so we have to talk about what is D asking for, right? It's saying, you know, for what value of X do you plug in, and it basically gives you 130 out, right?
Okay.
So from the picture, it's this picture, right? But instead of like in the first, oh, let me turn my video on. We can just talk about this because this is an important concept. So on the first three problems, what we're doing is this. Visually, here's what we're doing. We're starting with X's and they're getting taken over here, right? We're not going to say Y anymore. We're going to say we're going to take it over to some value of the function. This is like Y. So the first one is saying, hey, plug in 0, tell me what you get. So what'd you get, Shazia?
1.
1, good. So you just replaced X with 0, right? And you just got 1. Okay, how about -4? John Mesa, are you there?
Yes.
Did you try -4?
So -4, would it be -5?
I forgot what was it? It was you plug in -4 right here, right?
Yes. So it would be 3 times -4. So -12,
Mm-hmm.
and then +12 or +1 is 13.
-11.
Or negative-
You get
negative
-12,
11.
you're adding 1, right?
Yes.
So -11.
Okay.
So f of 0 gave us 1. F of -4 gives you -11. Did anyone do the half yet?
I got
Yes.
5 halves.
5 halves? Let's do this one. This one, you're doing 3 times 1/2 plus 1, right? That's what we're doing. So 3 times 1/2, look at 3 as being 3 over 1, just multiply straight across. 3 times 1, 1 times 2. So this should just be 3 over 2 plus 1, right? Now you have to add these fractions together, but that means you need a common denominator. Or if you do it the way I showed you the shortcut, you put 1 over 1 here, and then you do that little multiply. Remember that thing? We can do that. That will give you 3 plus 2 over 2. That gives you 5 halves. That is correct.
Excuse me.
Yes.
Since it's plus, it's 3 over 2 plus 1 over 1. Why
Mhm.
can't you say 3 plus 1? That's 4.
Because they don't have the same denominator.
Yeah,
Right.
how the denominator be 2? Since finding the common factor, I guess.
You could
So-
write it as 2 over 2. You could rewrite 1 as 2 over 2
Okay.
and then add them. And when you add them, you get 5 over 2 because you don't add the bottoms. When you add fractions, you only add the top. Is that what you're asking?
Yeah.
So either way you do it, you're going to get 5 over 2.
Okay.
Does that answer your question?
Yeah.
Okay. Okay, so in the picture, that means 1/2 got taken over to 5 over 2. Y'all with me? Part D is saying, hey, wait a minute, what X do you have to plug in? Okay, what X will spit out 130? So it's trying to, instead of giving us, you know, the number.
I'm
to
in
plug
school, what?
What's that?
Sorry.
No, it's okay. So instead of giving us the number and just saying, hey, plug it in, here it's harder. We have to figure out what X goes in and spits out 130. So the way you do this last one, and I'm running out of room here, but I'm going to try and do it, is to do this, we're going to take the equation. Now the equation, I'm sorry, the function is this function right here. We're going to ask ourselves, when is that function equal to 130, right? That's what we're asking ourselves. When is that true? And notice this is a linear equation with one variable. So all we have to do is solve it using the techniques we know for solving equations. Subtract 1 on both sides. So we get 129. And then last, we divide both sides by 3. And we get x is, I believe, 43. So the x value is 43. That means if we plug 43 in, it should spit out 130. That's a very important concept for what we're trying to talk about today, is if you have a function, if I ask you to plug a number into the function, that's part A, B, and C. If I ask you when a function actually achieves some value, then you're going to be solving an equation. You understand the difference between the two? Okay, let me give you a new one. Okay, let me give you a new one. We'll work together. So I'm going to, as we'll say, this is another example here. Let's say that we have a function f of x equals, I'm wondering if I should stay with lines or not. Let's stay with lines just for this one. Minus 5x minus 3. Part A, find f of negative 2. B, find f of 0. C, find f of 7. And D, find the x such that f of x equals 128. You know what? Let's make it, want this to work out nice for you. 122. So just take a minute to answer those. I'm going to start calling on people. I know you're not finished working them, but maybe we can work as we go here. How about Victoria? Are you there, Victoria?
Yes.
You want to help me with part A?
So you would do negative 5x minus 3 times negative 2.
No, all we're doing is replacing this negative 2 is just
Oh.
replacing the x, right?
Okay.
So it'll be negative 5. Then what's the operation here between the negative 5 and the x?
So negative 5 times negative 2.
Times negative 2. I'm gonna do it in parentheses just so we don't mess up the signs. And then we do minus 3, right?
Minus 3. Yes.
So you do the multiplication first. Negative 5 times negative 2. 2 negatives multiply to be a positive, right?
Yeah. So 10.
10. Take away 3.
7.
7. Okay, there we go. Right. Now I know we don't need this, but I just want to show you again the picture here. We have x. Here's the function's value. We plugged in negative 2, and this thing got sent over to 7. Right. All right. The next one. Let's see. How about Grace?
We're doing the 0.
Yes.
Okay, so you would plug in 0 where the x is, and then that would just be 0. So then the answer would be negative 3.
Negative 3. There we go. Okay. Good. So 0 gets taken over to negative 3, right? And then,
Can I do 2?
Yeah, go ahead.
So negative 5 times 7, which would be negative 35.
Yeah.
Minus 3, which would add to it, so negative 38.
Negative 38. Okay, so 7 gets taken over to negative 38. All right, who wants the last one? Tell me what to do for the last one.
I'll do it.
ahead.
What you would do is you would add 3 to both sides. Well, first you would
Hold on.
set
Yeah. Help me
one-
set up. You're doing an equation. What equation are you trying to solve?
122 is equal to negative 5x minus 3.
So that is what Nix is doing here, is saying that we want to know what X value you plug into this, right, to make it equal 122. So set the equation equal to 122. Okay, continue.
Then you would add 3 to both sides,
Okay. and if I do
canceling out the
that-
negative 3 and changing the 122 to 125.
Mhm.
Then you would divide by negative 5, giving you negative 25.
So X is negative 125. Good.
So for the last, sorry,
Go ahead.
I was gonna ask, so for the last problem and whenever it says that f of x is.
What the who?
And we just
But
plug it in.
John, I can't hear you. You're kind of like, you sound real muffled out.
How's that better?
There you go.
So whenever it asks for the find x such that f of x equals 122, we're just plugging it into the problem at the where the y would have been, correct?
Yeah, you're basically replacing the left side of this. This is kind of like the y, and you're replacing it with the 122. I like to say it this way. If it's asking for the x that makes a function equal to a number, set the equation, set the function equal to that number. That's all you're doing, is taking this and setting it equal to 122, and then solve. Okay, so picture-wise, again, parts A, B, C, you were given the stuff in yellow, right? You were given the input, right? This is almost like the input of the function. And you were asked to find the output. In part D, right, so A, B, and C, that's what you did. But in part D, you were given the output of the function and asked for the input. Does that make sense? So these are two different questions, two different types of questions. So when it comes to functions, all right, when it comes to functions, this picture I've been drawing is kind of to help you see something that we're about to talk about. If I were to try and visualize what this function is doing, like what it looks like, then what I could do is I could look at these relationships between these numbers and look at them as points on a graph. So for example, the first pair that we have here, 2 is my input, or sorry, negative 2 is my input, and my output was 7, right? So I can look at this like a point on a graph. The next one I have is 0 went in, and then negative 3 went out, right? That's another point. And then I could do the next one, 7 and negative 38. And then I could do the next one, right? Negative 25 and 122. So if I started to plot all these points on a grid, I could get an idea of what the function looks like visually. So I'm going to try and do that right now. So the first point I have is negative 2, 7. Now remember, the first number is the x, the second number is like the y, right? So if I go to the left, 2, negative 2, and then up 7, 1, 2, 3, 4, 5, 6, 7, I put a dot there. This point, negative 2, 7, represents a relationship for this function, right? The relationship of the input and the output. Make sense? 0, negative 3 would be, let's see, 0 down 3 would be another point. 7, negative 38. Uh-oh. 1, 2, 3, 4, 5, 6, 7. Here's 7. I have to go down 38. Okay, I'm not going to be able to. I'm probably going to run out of room. Should I? 1, 2, 3, 4, 5, 6. No, I'm not going to. But if we start to do all of these points we will get a feel for what it looks like. Now, for this problem, do we know what it looks like? If we were to try and connect these dots together, is it a straight line?
I think it would be.
Yeah, it would be, because remember where this comes from. This right here, really, we could have rewritten it back the way we started, replace the f of x with y equals negative 5x minus 3, right? And then everyone here hopefully would look at that and go, oh yeah, that's a line, it's in slope-intercept form. The y-intercept is -3 and it has a slope of -5. Does that make sense? So we know that if we connected these together, we would have a line, straight line. For this function, not all functions are lines, but for this one it is.
What
Okay.
about when it goes to the -25?
Pardon me?
As the last one is -25.
Yeah,
So,
I would have to go way out here to -25, and then I'd have
never
to
mind, I get it.
go up 122. And that line would eventually get there, right? Like it's going to keep going and going, and eventually I will hit that point over there somewhere. Okay, so what I want you to take away from this, because this next thing I'm about to do is where a lot of students have trouble, all right? If I have a point, just think about a point that lives on this line, okay? Think about this point. Whatever that point is, the x here and the f of x, this is the input of the function and this is the output, right? Which means when we went back to this picture, this was the in, this was the out, right? The x coordinate is what's going in, the y coordinate is what's coming out of the function. Make sense? Input, output. Now, let me show you why you need to understand this relationship. Well, I'm gonna do something a little different now. I'm going to draw a function. I'm gonna draw one for you. And then I'm asking you a bunch of questions about it, okay? So here we go. It's a new concept, still talking about functions, but it's a new concept. So I'm gonna have to take a moment to draw a graph with some accuracy here. There you go. I'll make this a little bigger, the grid a little bigger, so it'll be easier to see the numbers. Okay, so let me take a moment here. This is 1, this is 2, this is 1, this is 2, -1, -2, -1, -2. Okay, now I'm going to start drawing the function. Ready? Here it comes. Oops. Sorry. All right, just take a minute to draw that. Now, when I say that I'm drawing a function here, here's what I mean. This shape that you see in front of you is basically all of the inputs and outputs together. So, you know, there are just points everywhere on this thing. And when you put all the points together, it makes it look like a curve, like either a straight line or curved pieces, right? But every single point on that graph, on that picture, represents an input and an output. So I'm going to give you one specific example before I ask the questions. This point right here, I know you're still drawing. This point right there, I can tell from the graph that that's the point -3, 1. Can you all tell from that? It's -3, 1. I go to the left, 1, 2, 3, and then I go up 1, right? So whatever this function is, here's what I can tell you. I don't know what the function is. No one told me what it was, but here's what I can tell you. If you plug in -3 into this function, it's going to spit out 1. If I plug -3 in for the input, it's going to spit out 1. Do y'all understand that concept? Just by looking at this point, I know that the input is -3, that's the X value, and this is what comes out. So picture-wise, it takes -3, spits out a 1. I have no idea what the actual function is. Nobody gave it to me, right? I'm just looking at the picture of it.
So basically, we can look at the points and we can turn them into functions, like you're saying.
Turn them into inputs and
Or
outputs.
outputs, yeah.
So let me ask you the questions now, okay? Part A, I want to know what f of -1 is. Part B, I want to know what f of -5 is. C, I want to know what f of 0 is. D, I want to know what f of 5 is. I think that's enough for you to get a feel. And then for E, find X such that f of X equals 3. Find X such that X, yeah, let me see here. No one of these. Okay. I hope I've given you, I'm going to give you a little more time. I want you to see if you can answer these. All right, just looking at the graph, see if you can make the connection. And after I give you a few minutes, we'll talk about it together as a group. If you have a question, let me know. All right, you ready to talk about this? Let's start with A. Let's go with Doralee. How about A?
A, 2? Would it be 2?
Good. So can you explain to me how you did that? Just because your explanation might help others make sure they understand it.
So like on the top, the example where you put f of -3 equals 1, and then you point what's inside the parentheses is your x.
Okay.
So if x is -1, you find the point where that touches the line. And then the y would be 2.
Yeah, and you're looking at what y value that was. So this is the point -1, 2. So the y value is the answer. Yes, perfect. Good. Riley, what did you get for B?
I'm gonna be honest, I was kind of confused, so I didn't do it. I was just
Okay.
staring at
Well,
it.
let's walk through it then, okay? When you see
Okay.
this notation, they're telling you to go to -5 on the x-axis, okay? So let's walk over to -5, -1, -2, here's -3, here's -4, right? Here's -5. Now, look up and down and see where you have a point on the graph. Do you see that you have this point right here?
Yes.
Okay, so that has as a coordinate, -5 is the x. Can you tell me what the y coordinate is of this point?
-1.
-1. That is the output. The input is the -5, the output is the -1. So your answer is -1.
Okay.
That makes sense?
Mhm.
Okay, so I'm gonna put you on the spot. How about the next one then? F of 0.
Oh no.
You can do it. So 0 is the input, so 0 is the x-axis, right? So go to 0 on the x-axis. Look up and down. Where do you have a point on the graph?
2.
2. There you go.
Oh,
Right?
that was
Point
easy.
02. Well, it's easy once you see it, right? Like
Yeah.
once you understand it. If you don't understand it, it's confusing.
Right.
Do you want to show off and give us D?
Could it also
Not
be
really.
-4?
Wait, could it also be what?
-4?
For this one?
Yeah.
Where would you get -4 from? Oh, no, see, I think Doralee, what you're confusing it is with question G.
Oh,
He's
okay.
asking, when is the function 0? This
Okay.
is saying specifically, plug 0 in, what comes out? Go to 0, the only thing comes out is 2,
Oh, okay.
right? Riley, were you backing out or did you want to do 5?
I was kind of backing out, but I can do
You're
it if
backing
you
out?
need me to.
I want you to understand it. So
Would it be -2?
that's right. Good.
Okay, sweet.
Yep. So -2. And that's because we go 1, 2, here's 3, here's 4, here's 5. We look up and down. Up, there's the point down here. That has the coordinates 5, -2. -2 is the y value.
Yeah,
So
it doesn't
again-
help that I drew my graph kind of bad. So that kind of
Yeah.
threw me off.
Yeah, I'm sorry, because it's hard to transfer my picture over clean. So, all right, does that make sense to everyone? Parts A, B, C, and D. All of these values here are x's, right? Those are all x's. And then all these right here are the y's that correspond to those as points, right? Input, output, x and y. Make sense? Now, E, F, and G are harder because we're trying to find the x, right? We're trying to find the x's, so the x's are in yellow. We're trying to find the x's that give us these outputs. So these are your y's, and these are your x's, right? So this here, I gave you the x's, you told me the y's. Here I'm giving you the y's, and you're telling me the x's. So let's see. Amara, you want to go? Am I saying that right, Amara?
It's Amira.
Amira. I don't have my thing. Let me open up my thing and see if I had, I think I wrote that down on there. Hold on. Amira. I probably, Yeah, I even put it on here like to really stress the Amira. Sorry about that.
It's okay.
Okay, so Amira, do you understand this concept?
I think hopefully I do.
Okay, how about E? What did you get for E?
I got 2.
X is 2. What do y'all think?
Right.
What do y'all think? Okay, so the way you can do this, and that is correct, Amira. The way you do this is, since we're giving you the Y value of 3, right? 3. What I like to do is imagine going up to 3 on the Y axis and drawing a line straight across. And then asking yourself, do you ever hit that line? And we do, right? We hit it right there at that point. And so we have to go back down and figure out the X that it came from. So it's like working backwards. Instead of me giving you the X and you giving, and then you telling me the Y, I'm giving you the Y and you're trying to work backwards back down to the X. So 2 is correct. Now, there is an issue. There is an issue. Do y'all see this arrow over here on the right-hand side? See that little arrow? That implies that this keeps going, right? So it is going to hit somewhere over here, but I can't tell you where it's going to hit. No one could tell me. I couldn't even tell because I didn't finish drawing the graph. So X equals 2 will be okay as an answer for this graph because it's the only obvious given point. That makes sense, everyone? How about the next one? Anyone feel like they want to try the next one? The next one's a little harder.
I got -3, about 2 2/3, and then about 7.5.
All right, whoa, 3 answers. This seems crazy. Let's see. Does this make sense? So let's do that same sort of principle. This is the Y value, right? So Y is 1. I'm going to go up 1, and I'm going to draw a line across. I'll do it in gray again. I draw a line across like this. And I'm seeing, where do I hit the graph, right? Well, I hit the graph in these 3 green points. See that? Here, here, and here is where I hit. So we come down and we see, figure out where's the X value for this one. Now this one's obvious. That one's -3. Everyone agree? So that's this point. Good. Now, good. The next one, what did you say? 2.6, Nix?
Yeah.
So Nix is approximating this because it's hard to see it. Do y'all agree? Like, I didn't make it obvious what it was. So if you put 2.6, 2.7, 2.8, I don't care because it's not precise. The important thing is that you recognize it's happening somewhere between 2 and 3. All right. So Nix put 2.6. I will accept that. Good. There was one more over here. Where's it hitting? Well, this is 5, 6. This is 7. This next one over here would be 8. So anywhere between 7 and 8, Nick said 7.5. Good enough? We're approximating. These in red that I'm circling, those are approximations. Everyone could have slightly different answers and I'd be okay with that. Questions? Okay, how about the last one? Let me see. Chelsea, did I call you? I didn't call you, did I? Chelsea, no. Michaela?
Yes. Can you hear me?
Yes, I can. Do you understand the concept here?
Okay. Yes, sir. So it would equal -4.
Good.
3 and then 7.
Perfect. Okay, so what Michaela's doing here is figuring out where's the Y value 0. So you know how I've been drawing these lines across? This time we're actually drawing a line that's right on top of the x-axis. And Michaela's saying, where do I hit that? Well, that happens at -4, at 3, and at 7. Perfect. Are there questions on this? I'm going to draw another one now. I'm going to ask you a bunch of questions, and it's going to be a quiz that you're going to turn into me. I'm going to, you know how when you took your test, you took a picture and you uploaded your work? This is going to be, you do this on a separate sheet of paper. Make sure you put your name on it. This is very important. If your name is not on it, I'm not going to accept it. All right. So I will email you right after class. I'm going to email you a link, and you click on that link and you can upload your work. It should just be, you know, 1 page. It's due by the time we meet next time. All right. So before we meet again, which is on Thursday at 9:30 a.m., you need to have submitted this online to me. All right. Any questions on that? Make sure your name's on it. Just take a blank sheet of paper right now, put your name on it, put quiz 921, today's 921, right? Yeah, just put them. All right. So here we go. You have to give me a moment. I'm going to draw it. You're going to need to take your time. If you want, you can take a picture with your phone of the screen. That way you can copy it down later and make sure it's somewhat precise. Okay, here we go. And this will be it for today. Okay, from that, you should be able to recognize that each of these blocks is 1 unit, okay, in every direction, up, down, left, right. Okay, here's the function. I'm not going to do arrows. I'm going to make it just. Oops. All right, there's the picture of the function. This is the graph of f right there. And I will put the questions right below it. Okay, there it is. I need to look at your homework real quick out of the packet. So I'll put here on the side what homework to do out of the packet, page 85. Do 1 through 6. Page 86. 9 through 16. And that's it. And then this is the quiz. So you don't have to turn in your homework, of course. The problem number, page 86 is, let me show you what page 86 is. I'll put this graph back up, but I want to just show you what the homework is so you have some idea what's ahead of you. Page 85, they give you a function and then they ask you a bunch of things. Like what's f of -3? What's f of 4? When is f of x equal to 33? So we did this today. Do just 1 through 6. Now the next page, they give you a graph and then they ask you some questions, kind of like what I'm asking on the quiz. All right. And that is it. I'm going to email everyone right now the link to get to upload the quiz, and just remember it's due. I'll put it in the email when it's due. Are there any questions? You're free to go after you've copied this. Have a good day.
Thank you.
Thank you.
Thank you.
You're welcome. Have a great day.
Thank you.
Thanks.
Thank you. Have a nice day.
You too.
And you see Thursday.
Alrighty, thank you. Have a good day.
You too.